Welcome to the channel. We were discussing Fibonacci series. In the previous tutorial, we used recursion to solve this problem. Today in this tutorial, let's analyze time and space complexity of this program. Okay, so here we have our function. First, let's talk about time complexity. Here, this is the function header, which will take constant time. Then here we can see if condition. Here we'll perform comparison operation and will return the result. It also takes constant time. Then here next if statement, constant time, comparison operation as well as returning the result, simple operations. Next here returning the value, simple operation. But here you can see two recursive calls. Here the time complexity of this algorithm is mainly dependent on this. Here each call makes two more calls. Here we need to calculate how many times this function is called until it reaches the base case. We can visualize the function call like this. If I take n value as 5, Fibonacci of 5, this function will call Fibonacci of 4, 3. This will call so we can represent this like this. Every node splits into two new calls. Here number of function calls grows like this. This is level 0, 1 call. This is level 1, 2 calls. Level 2, actually 4 calls. Level 3, here 6 calls, but it can make 8 calls. So at each level, the number of calls roughly doubles. I'm not saying that exactly doubles, approximately doubles. And we can write it like this. This is as 2 power 0, 2 power 1, 2 power 2, 2 power 3. So at level n, it is 2 power n. Approximate calls, okay? Not the exact calls. Because here we are talking about worst case scenario. In the worst case, we'll talk about upper bound. It makes about 2 power n recursive calls. Approximate recursive calls. So here number of function calls grows exponentially, approximately proportional to 2 power n. Roughly it will take 2 power n calls. So we go of 2 power n. And finally time complexity is we go of 2 power n. This is the worst case scenario. So finally each call splits into two more calls. If this happened perfectly for n levels, we would have 2 power n calls. Even though some branches end early, we use big O of 2 power n to describe the worst case scenario. So this is about time complexity. Next, let's talk about space complexity. N is actually input to this algorithm and we are not using any other variable or any other data structure here. Then here we are using recursion. For every call, stack frame is created and it is added to call stack. To calculate space complexity, we need to see how many calls are made, how many frames are added to the stack. But here, even though it makes approximately 2 power n function calls, it doesn't happen all at once. Space complexity measures the maximum amount of memory used at any single point in time. The computer only tracks one branch from the root to leaf at a time. And here longest branch has here 5 calls, 1, 2, 3, 4, 5. Here n value is 5. So we'll have 5 calls. If here input is n, then n calls. That means n frames. It will take big O of n space. So space complexity is big O of n. Okay, so this is about space complexity. So that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I'll meet you in next class. Till then, take care.